All right, welcome to Sector 2009. I'm Kevin Fowler. I see some beside my phone ringing here. It's a faux pas. There we go. No more calls. So I see some familiar faces today, which is good. With my presentations, if anyone has any questions, don't hesitate to put your hand up or yell or do whatnot, and I'll do my best to answer them. There'll also be a Q&A session at the end. So whether it's during, whether it's after, if there's questions, don't hesitate. We're going to talk today about using database caches to detect SQL injection attacks, which I think is an interesting topic. Hopefully you feel the same way. Just before we jump into the thick of things, I'll tell you a little bit about myself. I'm Director of Security Services for TELUS backed by Emergis. What we are is we're a healthcare and finance application service provider. So we develop applications and we host applications as well for government, big five banks, list goes on and on and on and on. So that's what I do during the day. I fight fires, I try and keep data and transactions secure as they fly through our networks and systems. And by night, if that wasn't a busy enough job, by night I'm actually a security researcher. And I guess my passion or my focus is actually on Microsoft products. A lot of people ask me why I pick on Microsoft. I'm not picking on Microsoft. I like their products. I'm pro Microsoft and I like focusing on them. So that's why the focus of my research, especially of late, has been on Microsoft-related products. Some of my recent contributions have been applicationforensics.com, which is my website I own and maintain, and that site's a collection of all application forensic material. What that means is anything focused on the forensic analysis of applications, whether it's Microsoft or whether it's another technology. I try and capture as much research as possible within this site. I also post my research to that site, which of course is all Microsoft. But if you haven't been there, definitely go check it out. I've authored, it was just released December 2008, SQL Server Forensic Analysis, which is the first pure-play database forensic book on the market, which people are quite excited about, and I'm definitely happy with the finished product. I also wrote the database data encryption chapters for How to Cheat Securing SQL Server 2005, and the Best Damn Exchange, SQL and IS book, period. And I wrote the application security chapter for CompTIA Security Plus that just came out a few months ago. That's for the new SIS 201 certification. So that's about me, and let's jump into this session. Background behind the session. A lot of people say, what the heck are database caches, and how can you detect attacks within them? And sort of the background behind this session is, within SQL Server Forensic Analysis, I dedicated 3 pages to cache-based detection of attacks. Based on the people who read it and their feedback, they were extremely excited about this area. So I thought it was a good opportunity to spin off an entire talk. And this talk is what all of you guys are here today to actually see. So in this session, what we're going to cover is a high-level overview of popular SQL injection attacks. Okay, so some of the stuff that happened last year as well as earlier this year involving SQL injection. We're going to take a database cache-based look at these attacks as well, and attack detection, and that's focusing on Microsoft SQL Server. Other RDBMS products, whether it's Oracle, MySQL, etc., also use caches. The focus today would be on SQL Server, but the same concepts and techniques apply to other manufacturers or other products as well. Okay? And we're also going to look at a new database instance response tool that I've written. It's called Hypnosis, and it aids in investigator and attack verification. We'll get into that in the upcoming slides. Okay, so before we get into coming down to cache-based detection, we have to make sure everyone's on the same playing field with SQL injection. And SQL injection's been around for years and years and years. I'm sure 99.99% of everyone in here is familiar with SQL injection. But believe it or not, earlier this year I met a developer who had never heard of SQL injection. So I decided to put a couple slides in here just in case there are pockets of people who are not familiar with it. This is a simplified illustration I have here. With a web application with an attacker, the web application takes 2 fields, a username and a password. Okay? And based on what the attacker has put in here, he's put a username of Sebastian. I hope you can make this out okay at the back. And a password of y or 1 equals 1. And what SQL injection is it's actually malicious commands that alter the back-end logic of SQL statements processed within the database. All right? So looking between the web and the database server, if you look at the actual command that would be processed and sent from that web server / application server to the database server, it shows select user ID from users, where username equals Sebastian. There's nothing malicious with that. And password equals Y or 1 equals 1. That's where the malicious statement comes into play. And what that does is it changed the logic that was looking for a result set that matched a username or password that should return true. But by including the or 1 equals 1, that always results in true, regardless if the right username or password was entered to begin with. So that's a way to bypass and trick the database server into going back to the web or the application server saying, hey, this user authenticated successfully. All right? So looking at this, is this a database problem? No. SQL injection vulnerabilities exist within applications, both web-based as well as client-server applications. Most of the attacks we hear about today focusing primarily on web applications. They make news. Everyone's talking about web application-based SQL injection attacks. Truth of the matter is, any application that takes user input and uses that input to craft SQL statements can be vulnerable to SQL injection. All right? Point in case, client-server applications, database or RDBMS products out there are client-server applications. Looking at, again, squarely at Microsoft SQL Server, the MS drop retry and the MS drop temp table are two stored procedures. These were developed by Microsoft developers and shipped with the RDBMS platform. And there were SQL injection vulnerabilities that were actually discovered within these stored procedures. These could be executed not by a web application, but anyone who is either on the SQL Server and called them, or anyone from a remote client that could call these stored procedures. So anything taking user input in crafting a SQL statement or processing that input can be vulnerable, and that's just an example of that. And the question I'm asked a lot, actually, are certain databases more vulnerable to SQL injection? Not exactly, but some products and programming languages support stack queries. All right? And if you look at a web-based exploitation scenario, you have to make sure that the web application that's receiving the client input supports stack queries, as well as the database server that it will send the stack query to. Right? So a combination of factors actually will allow a stack query-based attack to be successful. And some of the usual suspects, we've got Oracle, MySQL, SQL Server, ASP, ASP.NET. The list goes on and on and on and on. But all the popular development languages and the popular database platforms out there all support stack queries. And looking at what stack query is, if you look at the syntax I have at the bottom of the screen, it's select employee ID, fname from ssfa.employee. SFA.employee is the actual table name of the statement, where status equals 1 and fname equals Isaiah. And then if you look at the actual semicolon here, which should be highlighted, but it looks almost highlighted in your version, but the actual semicolon terminates that original statement and then adds an entirely new statement to the end of it, which is drop database SSFA. All right? So in effect, there's two statements that are actually stacked together, added together, and that would be executed by the actual database platform. So when we look at stat queries, when we look at SQL injection, instead of trying to manipulate the Transact SQL language to try and return different data, we can now stack an entirely different query to execute an entirely different set of results, over and above what was initially intended within the actual query or the logic that the developer wrote. So stack queries can be extremely dangerous. But at the same time, stack query-based attacks can also be easier to investigate. And we're going to get into that later on. So a lot of people say a lot of bad things about stack queries. They can be a good thing from an investigation point of view. We'll talk about that in an upcoming slide. So SQL injection attacks in the news. Everyone here, I'm sure, knows SQL injection attacks have been around for years and years and years and years. Is it a problem today? Absolutely. It still dominates the headlines. Back in August, I think charges were filed against a group of hackers that compromised 5 major card processors. Out of that compromise, they netted 130 million credit and debit card numbers. That's the largest security breach that was actually reported in U.S. history, and I'm pretty sure in the world, actually. But massive. And the way that breach was carried out, our attackers gained entry to the different organization networks via SQL injection, and then installed software that would pick off transactions and actually scan systems for this credit and debit card information. So pretty scary, and SQL injection was the catalyst that these attackers used to get into these major organizations that all have security teams, that all have security controls to infiltrate and carry out their attack. And also 2 major antivirus vendors this year, their websites were hacked by a SQL injection. And I'm not going to mention names when it comes to AV vendors. A lot of people assume AV, they're in the security space, they should know better for SQL injection. I would say that they are no different than any of the 5 organizations that were hacked or anyone else in this room today who has suffered a security incident at the hands of SQL injection. You have security teams, you know about the risk, but there's reasons why risk doesn't get addressed. We're going to get into some of those reasons in the next point, which is it's often the attacks you know about that are successful. It's not as if you're caught completely off guard and you had no idea a certain class of attack was executed. In most cases, you know about the attack, you know the systems you have, but for some reason you still get compromised. People have a hard time figuring that out. My theory on that is knowing is half the battle. And that's drawing a parallel back to a few years ago, SQL Slammer. When that was released, how many security people do you guys know said, who the heck would expose an RDBMS to an untrusted network? That's ludicrous. They knew about a handful of servers that they kept there on their raised floor environments, we'll say. They patched those servers, they made sure they were protected, they called it a night. They came in Monday morning and all hell broke loose in a lot of these environments. Because it's not the servers that they knew about in that small group, it's the other instances that were installed silently via other applications, which was MSDE, which are these little tiny database instances that Microsoft releases, or the other, even production servers that for whatever reason weren't in their inventory or they didn't know about. So a lot of organizations who thought they were safe really weren't safe and actually got pretty badly compromised by this. And when we look at SQL injection attacks, just the nature of vulnerabilities. There's vulnerability scanners out there you can use to detect a lot of these attacks. Manual detection can be used as well. And these are all good approaches at addressing all the entry points that are vulnerable and can be exploited for SQL injection. But all of these, whether you're using one or whether you're using both of them in combination, won't detect all attacks. It's impossible. There's no way to do it. You're dealing with web applications with thousands of pages. Each of these pages can have multiple entry points. It's impossible for one method or even a combination of methods to detect all vulnerabilities. And it takes one attacker to find one of the vulnerabilities that were missed by either your product or your manual review to actually exploit. And even when your manual detection or your actual vulnerability scanners do turn up vulnerabilities, they're not exactly easy to fix. Some vulnerabilities, you detect them, there's a patch, you can push out a patch via whatever patch management software you have, the problem goes away relatively easily. With web applications, it requires developers looking at the code, pulling up the code, identifying through thousands of pages all the areas that have these vulnerable entry points, addressing it, regression testing, promoting from different environments into production. Extremely expensive. So in some cases, security people identify vulnerabilities, they raise it to business, but business in some cases will sit on the vulnerabilities or put a plan in place to address them, but not immediately. And this sort of cocktail or these factors are a large reason why organizations still have these vulnerabilities today that are currently being exploited. And that's a risk I'm sure a lot of people in this room actually are facing as we stand. So that begs the question, what do? You can only detect a subset of them. Even when you detect them, only a subset of those get fixed. What can you do? Just try and do your best, fix what you can, and proactively protect your applications. Right. When it comes to protection, IPSs, web application firewalls are all popular controls to prevent attacks, which I, for one, am a big supporter of these controls. And IPSs themselves have actually become a default level of security within an environment. If I see an architecture document for an environment that's being architected and there's no IDS system, that's a red flag for me. I'm sure it is for a lot of you other guys out there as well. But at a bare minimum, you need to have an IPS. Web application firewalls present different challenges. If they're configured correctly and they don't break anything, as Hoff mentioned earlier, these can be effective as well. At the same time, because they're well known, because they do provide good levels of protection, you have attackers who will actually go out of their way to find ways to try and circumvent detection via these controls. In addition to the attackers, though, just good security principles sometimes works against us. And by applying security in some areas, it actually creates blind spots in our network that we can't detect attacks that traverse these areas. And we're going to talk about why in 1 second. Probably the biggest issue organizations face when detecting SQL injection attacks are encryption, whether that's SSL or IPsec. So encryption by SSL, Hoff mentioned as well. There's a lot of points that Hoff mentioned in his keynote that's covered here, and he stole my thunder in an upcoming slide, which we'll get to in a few minutes. But encryption, SSL encryption, whether it's regulatory requirements, something like PCI, whether it's just making sure your customers have that warm and fuzzy and feel secure, people encrypt transactions. When these transactions are encrypted, a lot of times these transactions traverse networks that aren't picked up by IDS because IDS can't detect vulnerabilities in traffic it doesn't understand, which is encrypted traffic. Some vendors have some solutions, so there's some versions out there that will terminate SSL, will scan traffic, and will re-encrypt and send it back. Adoption, based on what I've seen in the industry, is not that heavy. So no matter which way you slice it, that's still a major problem organizations face. And IPsec encryption is another. Well, IPsec policy specifically, if you look within Windows 2000, it allows the ability to encrypt traffic sent between any two servers. It could be web servers, database servers, application servers, all within a NIC, and it's all encrypted, and that will bypass current, whether it's web application firewalls or IPSs, devices that are on the network. So that's a big one, and that's more design. Things we do to help secure our network actually prevents our ability to detect attacks on the same networks we're securing. Concatenation, which works to help break up signature-based detection tools. And that's basically breaking up different words to try and beat key match and regex expressions, etc. Variables can be used with concatenation. I don't want to spend a ton of time on these. SQL comments is another way to break up syntax, so union, select, union. Whether it's concatenation or SQL comments, the database server gets those, puts them together and reassembles, and will execute it as if it wasn't there. But if you're looking on the network, then you could definitely have some issues if you're looking for specific signatures. White space is another thing that falls in the same bucket. Too much or too little, that can help bypass different searches people do. And encoding as well is big. So if you look at just encoding in Sector 2009, I'll break encoding up into two categories, application-based and database-based. The first two are application, which are Unicode encoding, which looking at Sector 2009, looking at that string encoded within Unicode, you can see actually right beside it what that will look like if you look at that on the network. Likewise, URL encoding, what that will look like. Those are at the application level, as I lose my mouse. Hex encoding, though, is done at the database level, meaning this is going to be submitted, we'll say, from an attacker site. It'll be sent over the network, hex encoded, to the web server. The web server will terminate that, will create a session back to the database, so it'll still remain hexacoded and be processed by the database server. Okay? And car function is no different. It will follow the same example that we just walked through for car encoding. So depending on the encoding levels, it could be corrected at the application layer or it could be corrected at the database layer. But regardless, it's designed to help evade detection by different controls. This is an extremely busy slide, so what I'm going to do is I'm going to start in the top left. Attack detection should happen in multiple areas in your network. There's no doubt about that. And as you move further back in your network, attack detection can actually become more successful when you're looking to identify SQL injection attacks. Based on this scenario here, we have a user who's executing an XP command shell session to do something with the user account. It might be adding, deleting, who knows. But it's a stack query is what he's executing. And this is a typical environment that a lot of organizations have, and it just helps re-solidify some of the challenges we talked about on our last slide. So that statement, that stack query, will fly across the network, encrypted via SSL, so it won't be picked up by IDS or web application firewall. It'll be processed in the web server, and assuming that it was on a secure page that normally transfers secure data. It will be done via HTTP post, which by default isn't logged in a lot of applications. There are ways around that, and you can actually start to log post data, but you need to actually consider to yourself, logging post data within web server logs is often not the best course of action. There's a specific reason why it's not logged, and because it normally contains sensitive information. Now, dumping all that sensitive information within a web server log that sysadmins and developers, et cetera, have access to is another thing to try and secure. So post data normally isn't logged, and for the most part, it's sort of better to keep it that way. You have a web server, and then if it's sent back, whether it's SSL, so whether it's encryption done within the database server itself, between the database server and the web/application server, or whether it's an IPsec policy within Windows, attacks encrypted will fly through all the way from the hacker to the database server encrypted, so it will pass through a lot of the detection controls that you can put on the network. So when we look at attack detection, looking at the database server, which is sort of the end destination for all of these attacks, especially when dealing with SQL injection. Database server-based controls are what we need to look at. Controls such as database monitoring agents, web application firewall agents. Some of these controls have agents you can apply on the machine. They monitor transactions, database activity, etc. Host intrusion prevention systems. All these are good forms for attack detection. They're good controls. I definitely like using these. They do require, though, investment, premeditation. You have to get the business approval. You have to deploy them. You have to configure them. You have to test them. And more often than not, these controls will not be in a system that you're called to do an investigation for. And that's just Murphy's Law. Worst case scenario is what you need to look at. If I'm called to do an investigation, we'll say 2 a.m., 3 in the morning, I'm going to pray to my lucky stars these controls are in place. In reality, though, in most cases, they probably won't be in place. That's just based on what I'm hearing in the industry. Right? So in absence or addition to, if somehow you've managed to get these controls in place, they're on your database systems, or if you don't have these controls in place, regardless, look at the database cache. Because the database cache is an integral, it's an always-on component of a database. It's not an option that has to be enabled. You don't have to configure, you don't have to harden a server. As soon as it ships the factory, as soon as you install it, it has a database cache. Caches to databases are what breathing is to us humans. It's natural, and it's just something we always do as long as we're healthy. And that's exactly what databases do, is they cache. And one of the reasons why it has been an integral part of a database since day one is because it doesn't have security in mind. Most database products, Microsoft SQL Server is no different, was designed at a time where security was not a major design consideration. Performance, however, was. And database caches help performance. So it's integral, it's always on, you don't have the option to turn it off, because Microsoft wants a fast and efficient system. And it actually helps us security guys by looking at caches that are always on, that can't be disabled, to help qualify different attacks. And databases with caches, they maintain several caches. Looking at SQL Server, there's 4 different caches that they actually maintain. We're going to be focusing on one cache here today. And that cache is an SQL plans cache. Within this cache, the type of information that's actually stored and logged are ad hoc SQL statements. Okay? And by ad hoc, that's your select statements. Those are your inserts, your updates, your deletes. Stack queries are in there as well. If you execute stored procedures, extended procedures, everyone here has heard of XP command shell, XP read read, all your extended procedures, all your ad hoc SQL statements are all logged in this cache. Okay? And this is most statements executed by a database system will be logged. It's not perfect, not all, but most statements will be executed. Okay? And why database? Databases cache plans. I sort of answered that question with my previous point. But it's for performance. And that's why when you execute a command within a database, you execute it once. It goes through. It takes maybe a few seconds to complete. You execute that same statement again. It's much faster because it has a cache plan. Okay? And what databases do when they actually, when you submit a statement to a database, we'll say it's select star from a table. That database server will take a look at your statement, look at the schema of the database, and say, what's the most efficient way for me to actually retrieve data from this database? Databases are complex structures. They got indexes, they got statistics, they got all these different ways a database can pull information out. So it puts together a plan on the most efficient way to do it and logs that plan. Okay? And by logging that plan, it took effort for a database server to actually put that plan together. So it tries its best to hold on to that plan. It saves it and stores it with the hopes it will get another query that it can reuse the same plan for. Okay, so just that's a Coles Notes overview of what plan development is within a database. And looking at SQL injection traces within the plan, here's an example of a SQL injection attack within the plan cache. And the statement is select employee ID, first name from SSFA.employee, where first name equals Isaiah or 1 equals 1. And as we can see, it's a stack query. it has that semicolon, and then it executes an XP command shell statement, and that's adding a user account named Isaiah. And to go further, it actually has a comment in here. To further prove this point, can you see this comment? And most people think caching, and they think database statements. They're going to assume, OK, based on that, there are two distinct areas within this query. A, that first select statement will be cached up until the 1 equals 1. Then another cache entry will be created for the execute XP command statement. And the comment, it's not processed by a database server. It won't be cached at all. That's not actually the way it works within the internals of a database. Okay? Database servers cache batches. And what a batch is, it's a collection of one or more select, insert, or update statements, or any stored procedures, extended procedures that are executed, but it caches several statements into one. And that's a good thing for attack detection, because if a database server was to separate this out, it would be much harder to find something malicious within the cache. One select statement here and something else that's malicious somewhere else. If it's somewhere else, it might not stand out as malicious. But actually seeing a malicious statement stacked to a legitimate statement is sort of a red flag in terms of cache detection within the database. Further, a common method that attackers have for executing SQL injection vulnerabilities is they enter in their own syntax within variables. They specify their own logic, and then they comment out the logic that was intended to be executed by the developer. Okay, so we can actually look at the comments that are cached as well and see is there legitimate logic that's been commented out. That, again, is another red flag for a successful SQL injection attack that has been carried out against a database. And looking at our SQL injection attack syntax and moving down to the actual text entry, this is the actual entry that's cached within a database server. And we can see the entire statement has been cached together as one batch, including the comments as well, which is pretty interesting. And there's two different ways you can look at a cache entry. You can look at it in a text form or a graphical form. And I've added the graphical form down here just so you can see about what type of things the database server takes into account. And it looks at cost. 100% of the work to do this is all in the select statement. But that just goes to show you some of that performance stuff that databases like doing, and they cache plans. So there's two different ways to look at it. And these plans, of course, take time. Database servers, once they create these plans, want to hold on to these plans for a long time so they can reuse it and get their money's worth out of it. Question? Nope, and we're going to get to that on the next slide. It's a good point, though. You're one slide ahead of me. 2 slides ahead of me, actually. But I'll answer that 2 slides from now. But no, it's not persistent through reboots. So we look at cached entries. Some cache plans that are created by SQL Server are actually parameterized. Okay, and what parameterization is when the database server takes a literal value and replaces it with a variable. Okay? And it does this to try and get the most use possible out of a plan that's been created. An example I have here is an actual parameterized statement that was put together by the database. And we're just going to skip to the select statement here. It's select information from a table where status equals, and this was the literal value, and that's been replaced with a variable. And first name equals, that was another value, and that's been replaced with a variable as well. Okay, and database servers do this so they can get another query that was similar but may have different literal values, but that can be swapped out, and they can actually reuse this plan for more than one occasion. For instance, select employee ID, first name from SSFA.employee, where status equals 1 and first name equals Kevy. It would use that plan. Another example is the exact same query, but where status equals 2 as opposed to 1, and first name equals Derek as opposed to Kevy. It would reuse that same plan because it swapped out the literals with variables that can be swapped. All right? So parameterization is good for databases because it helps control the size of the plan cache. It helps reuse of the plans that are actually created. But it's bad for cache-based attack detection. Does anyone here know why it would be bad for cache-based attack detection? A lot of poker faces here. Anyone? Okay. Exactly. The actual payload of a SQL injection attack will actually be swapped out with a variable, and to simplify it, will be lost. In reality, though, as the statement's processing, that information is stored. And from a history point of view, the last actual values that were used within a parameterized statement are actually kept. But everything in between is lost. Okay? So it's actually bad for attack-based detection. But the good news is that a lot of SQL injection attacks, meaning the syntax that the attackers use to modify the logic, in some cases to evade detection by different network-based controls or other controls, whether it's a manual log review, work against them once it hits a database server. Because a lot of these advanced arguments and advanced commands such as in, union, into, select into, top, wait for, that's commonly used for blind SQL injection, subqueries, expressions with an or in the where clause, comparisons between two constants where AAA equals AAA, statements submitted via the execute string. All of these things that are sort of normal fare for SQL injection attacks force the database server not to parameterize the statement, but to cache it in its entirety. So the same thing hackers do to avoid detection work against them and actually forces database servers to log their actions. Okay. Looking at planned cache limits, so we know that SQL injection attacks are often cached. Looking at the size of the planned cache, it varies depending on the version, the edition of SQL Server you're using. This is a slide with a lot of complex stuff. I'm going to try and condense this in about 30 seconds or less. So if we look at the SQL Server version in that table here, we're going to skip the cache pressure limit. For any of the die-hard SQL people in the room, you can look at that middle column. For everyone else, we're going to skip that, and we're going to jump right to the end. There's basically complex formulas that SQL Server uses to help determine the size of the plan. An example is on a server with 28 gigs of memory. On SQL Server 2008 and 2005 SP2, 5.4 gigs of that memory will be allocated to the planned cache. And it can actually store all of these SQL injection attacks that were hit. Okay. Jumping back a release, SQL Server 2005 RTM, which is Service Pack 0, and Service Pack 1. On the same 28 gig server, that's 16 gigs of memory. And that's something Microsoft changed the caching between 2000 and 2005, and they were much too willy-nilly with it. They got a lot of complaints about planned caches, filling servers, etc. So they corrected that with Service Pack 2 in 2008. But it's good from a detection point of view running into either 2008 or anything before 2005 SP2. And likewise, SQL Server 2000 had an upper limit of 4 gig of memory that will be allocated to the planned cache. So the next logical question is, how long are these things kept? If anyone here was to offer me $1 million to answer how long, I couldn't tell you, nor could Microsoft. It's complex. Again, it's many factors. I've captured some of the factors down here. Memory pressure, internal or external, how busy the server itself is, or how busy the SQL Server instance is in terms of CPU, in terms of memory it uses, number of times the cache plan is used. If a cache plan has been used a couple times, it'll hang around longer than one that's been used once. The amount of server memory, which we discussed, manual clears or manual purging of the cache, that's something that can be done as well. I'm not going to tell you the commands and how to do it, but that's something that can be done. Changes to associated objects referenced by cache plans, that can help affect it. The size relative to other database caches. Again, SQL Server, there's 4 caches. You've got one cache that's huge, another cache that's small. SQL Server is going to try and level that playing field. All right? That's a good question. I'm not aware of any impact by clustering, as long as these factors will be consistent, whether it's a single node or whether you're running a 32 instance box. It really doesn't matter.
Does it carry the plan across clusters, or is it per box?
That's another good question. I don't have an answer to that. Is it per box or is it instance? The way clustering used to work was active-passive. I'm not sure if it's active-active now. If it's active-passive, of course, the cache will just be on one box. If it pills over to another box, I would imagine that cache entry would be lost. I'm not exactly certain, though. That's a good question, though. Yes?
So does that mean it's only memory resident? It's never persisted on disk?
Absolutely, and you're right on the mark, actually. My next bullet is a restart of MSQL service will actually clear the cache. And that's because the cache is only in the memory. It's never written out to disk unless it's paged or swapped as part of another process. But the database server doesn't write it to disk with the hopes of retrieving that from disk. It always stays in the memory, these CAN flash, or these planned cache. Try saying that 3 times fast. Planned cache entries. Okay. answer your question?
Yeah, so that would suggest that in the case of a cluster failover, that it would not persist across the failover.
Yeah, exactly, and that's the point that we just talked about here. Yeah. So looking at cache-based attack detection, we covered what the cache is, how the attacks are captured within the cache. The good, or one of the positive things about this is it can actually take the guesswork out of an investigation. Whether you have someone who reviews a web server log entry and identifies something that looks like SQL injection, or whether you have an IDS event or some other event that's gone off on the network, that just shows you that, hey, that attack was seen upstream. It doesn't mean it was actually processed by the application and sent back to the database and successful. So it's one of the negatives. They still require investigation. Looking at entries within the actual cache actually proves that that attack was tunneled from the attacker through the application all the way back to the database. So it helps take the guesswork out of qualifying a lot of these events by seeing the attacks that were actually processed by the database server as opposed to just sent over the network. Okay? And attacks generally leave specific fingerprints within the cache. Depending on what you're doing, database enumeration, reading, modifying, deleting items, reading registry backdoors, changes you're making to the database schema, etc. All of these actions generally create these cache entries within the database. And the method that you're using for SQL injection will actually dictate the amount of entries that are logged within the cache. A good example are blind SQL injection attacks. Extremely noisy, extremely loud, and that will literally light up a cache like you've never seen before. And enough about cache, enough about specifics of internals of SQL Server. We're going to get into some of the attacks. Some popular attacks that have been out there, again, earlier this year, and some of the big ones from last year, and what they look like in the actual database server cache. So we have the mass SQL injection worm that affected over 500,000. In some cases, I heard pages. Some cases, I've seen sites. I'm referring to sites here in 2008. The interesting thing we see here is this is the actual payload of the worm when it was executed by that server. So it was tunneled through the application and executed by the server. I don't want to get into the specific syntax of this, but I have highlighted an execute statement. And sort of the high-level overview of what this is doing, it's scanning metadata to find all the tables within the SQL Server. And when it finds a table, it triggers an update statement, and that updates the values within the table and appends some malicious syntax at the end of it. And that will allow, if a web server extracts values from the database, the thought is that it will provide a malicious link and redirect the user to another area and download malware. Right? Which it did work well. But the point I want to draw attention to is the point that's highlighted in yellow, which is the execute statement. In addition to the actual payload of the worm that was cached, the actions the worm actually carried out within the system are cached as well. So every time it found one of these tables that it needed to update, it span off another action, and that created a separate cache entry. So you get the payload as well as the actions within the worm. You can actually step through that cache and find point by point the actions that the worm actually executed on the system, which is pretty interesting. I'm not sure the correct pronunciation of this tool, but Kinetics is what I'm going to go with. It's a tool used in the attack of a leading AV site that was earlier this year. And reports have it that an attacker used this tool to scan the site. This is an extremely advanced tool that allows a lot of customization. But he used a customized version of this tool to scan a site, to identify a vulnerable entry point, and actually exploit that manually via SQL injection. But this is the same tool that was used in 2009 to compromise a major AV vendor. Again, I'm not going to mention names. And sort of one of the cache entries left behind is, as we can see, SQL comments is what it's trying out, and it's just trying to get its bounds as to what it can do within the application. SQLMap is an interesting tool. It was created by Bernardo. He's a very good researcher, actually. It was debuted at Black Hat DC earlier this year. And a lot of people know that there's different commands, there's different procedures within a SQL server that allows you to jump from the database server itself out into the actual operating system that the database runs on. And this is a tool that actually automates the exploitation of the operating system through SQL injection. Right, so it makes it nice and easy. It's a very good tool that was written and got a lot of press, actually. And the thing I like about this tool is everything works on it. A lot of people put out tools or put out POCs, and they only work in limited cases. Every feature I've seen within this tool works well. So I think Bernardo's done a great job. But one of the entries, one of the plan cache entries that were left after banner enumeration is down here, which we're not going to get into the syntax, but it's just enumerating the banner. So it's enumerating the version of SQL Server that's actually being used by the back-end database. And this is one of over 1,490 cache entries that are created by just the banner enumeration. So that just goes to show you the level of caching that actually goes on within the system. And sorry, we have a question? I'm sorry? Absolutely. We're going to get to that later, but any payload of a SQL injection attack that's either hex encoded or char encoded will be hex or char encoded within the actual plan cache. Because database servers see that and they process that in real time. Okay? So encoding at the database level, it will still be encoded within the plan cache. Does that answer your question? Perfect. And we're going to look at an example of that in a few slides. And Pangolin. Has anyone here used Pangolin? No? This is, in my humble opinion, one of the most dangerous SQL injection tools out there on the planet. It was actually released by Chinese-based hackers, and it actually gained a lot of attention, and even Harlan Carvey is probably the most well-known Windows incident response and forensics guy out there. But even he's blogging about this tool. It's extremely serious. It does basically what SQLMap does, but with a GUI front-end interface. And it includes unhardening buttons that I put in quotes here. So even if you lock down a SQL server, in some cases, people will look at XP command shell or XP reg read. People disable that. In some cases, they go a step further and they deregister them from the SQL server. You can hit one of these unhardening buttons, and it will re-register that library in addition to re-enable it. And not to mention, even if you're a hacker who doesn't really know what to do, but just knows you want to hack, it has built-in commands, and it basically instructs you what to run. So if I stumble on this tool, I point it to a vulnerable site, and I get access to the site, I can just literally hit the drop-down and say, OK, that's cool, get the information I need to carry out another attack. So it's almost intuitive, and it kind of leads you to hack these sites. But extremely dangerous, extremely, extremely dangerous. And one of the examples, we had a good question back here, is if hex encoding and char encoding is actually there within the plan cache. Looking at the plan cache entry that's created by Pangolin down here, we can see that that is hex encoding. And this is hex encoding of the same values up here, which is the registry hive and the registry keys that are being read. And this is this tool going through a SQL injection vulnerability and reading these local settings on that database server it's compromising. That it's all hex encoding. And to convert that from hex back to something that's human readable, you can just use convert or cast. There's a lot of functions within a database system that you can do that. Or you can go old school and look at an ASCII table and do it yourself. I don't know why you do that. But you can actually see, if you saw some of the other tools that are designed, either commercial products or more proof of concept tools such as SQLMap, they got nothing to hide. When it comes to Pangolin, they're doing hex encoding, so you know that something's up. Okay, so we know about the cache. We know there's bad things out there that are tracked in the cache, and how do you get to them is the question. Well, SQL Server 2000, you can access the cache directly by querying the system tables and system objects. In SQL Server 2005 and 2008, of course, there's that abstraction layer Microsoft put in place. So you have to access the cache through DMVs, which are distributed management views. And through these views, these views themselves can be accessed by ad hoc TSQL. If there's any hardcore SQL people or programmers out here who know SQL, you can write your own stuff that will get you access. Easier ways to do it, though, are a customized incident response framework, which is WFTSQL. Is anyone here familiar with that? Give me at least one hand. One hand. Someone. No one. WFTSQL is a database extended version of Windows Forensic Tool Chest. Windows Forensic Tool Chest is a very successful incident response tool. It runs commands. It gathers results, and the MD5 hashes the results. Okay, so it's good from the incident response forensics point of view. And it was written by Monty McDougall. I worked with Monty to extend WFT to include the database as well. So you just have to enter in the database instance. It will actually go into the database and collect, I think it's 19 different artifacts. But that's the only incident response framework that's extended to actually grab database artifacts as well. And that's free. That can be taken from applicationforensics.com, or it's on the companion DVD for SQL Server Forensic Analysis. But sort of leading to where I'm going with this is Hypnosis, which is a new tool I wrote. It's a new alternative. And the name Hypnosis I got just based on what the police do when they interrogate people. In some cases, they lock them in a room, like you see in Law & Order, and they order pizza with lots of onions, and they interrogate people, and they try and get all the information out of them. In some cases, though, they put them into a state known as hypnosis, and they interrogate people through hypnosis. And what that does, it allows the subject to recall events from memory that they can use to either prove or discount an event. And that's sort of the same thing that hypnosis does. It talks to a SQL server and allows the SQL server to retrieve past events that it's storing in cache in memory, and that hypnosis, the utility, uses to determine if an attack has occurred or not. So the same thing applies, so I came up with the name Hypnosis. It's a C# command line application, which I'm not sure how many people here use C#. Do we have any C# coders here? That depends on the .NET framework's a killer. So I'm thinking about going old school and changing that to VC++. As things stand now, it's C#. It's minimal disruption to a SQL server, meaning it's very small footprint. It creates only a few cache entries itself. Any interaction you have with the SQL server will create cache entries, and this creates only a few. So I spent a lot of time making sure only a few entries would be added by itself, and it uses a regex-based rule file that you can put fingerprints in there and look for different signatures within a cache. So the thought behind this is you can actually get an IDS event. You can look at a web server log and see a strange entry. You can actually look at that entry, create your regex expression, throw it in a rule file, run Hypnosis, and it can actually verify that attack for you if it was actually executed by the database server. That's the thought behind it. And I have a demo for Hypnosis. And earlier in this discussion, sort of before people filed in, last year I presented at Sector, and I had a possessed projector that was changing and flipping slides. Anytime I try and do anything audio-visual, something goes wrong. What I've done here with Hypnosis is in my controlled environment at home without all these crazy goblins or ghouls, whatever you want to call them, that control my audio-video. And I've put together a video of Hypnosis in action. That's something we're going to watch now. You can actually see the tool, and we're actually going to walk through a demonstration of Pangolin, which actually exploits a vulnerable application, and we use Hypnosis to detect exactly what happened within that. So we're going to jump to that, and hopefully I can hit play without causing an issue here. And I'll give the play-by-play on this as we step through. So the rule file we talked about, I'm just going to open that here. And these are the actual signatures that I put in place are all around Pangolin. So the different features of Pangolin, some of the thumbprints I leave within the cache, I've captured those using regex signatures and put them in the rule file. Okay? And that's just giving you a view into what that rule file is. Now what we're going to do is we're going to execute Hypnosis, and it's going to scan the database server and come back with 0 findings, and that just proves the base is clean. So I'm executing Hypnosis, I enter the name of the instance, it connects, it checks the cache, and it's come back. You probably can't make that out, but with 0 potentially malicious cache entries detected. Out of 1,491 were scanned, and it gives you the time frame of the cache entries as well. This is the results file that Hypnosis puts forth, and as you can see, it's blank minus the banner showing you the format of the results, assuming there were any. Now we're actually going to exploit a web application via Pangolin. It's kind of cool. You get to actually see this tool out here, which is extremely dangerous. And again, this is publicly available. Anyone can hop on Google and find it within 30 minutes and do a lot of bad things. You enter in the URL of the application as well as the variable, in this case, the query string that has the vulnerability within it that can be exploited. This is a box on my lab, and you hit the Go button. And what it does is it checks that application and verifies, yes, it is vulnerable. It's come back saying that that's a string that's mapped to that variable and the version of the database in the back end. And then says, where do you want to go from here, which is Microsoft's tagline. You can get the version, database name, server name, system user, current user, privilege, databases, drives, local groups. I hit select all and hit go. And within seconds, it comes down and completely enumerates that system. It tells me the version, the database, the server, the privileges I'm connected with, the account, the database is on there, and the actual drives on the local system. And that's easy, and that's all over SQL injection by the web. All right. I'm just going to step through on the command window. This is XP Command Shell, and it gives you the interface as if you're actually there on the server. And it's already pre-populated with one of the hacker commands here. And these are some of the unhardening buttons we talked about, which is restore. different extended procedures. I hit execute, and it's just like I'm there on the system. I'm doing this via SQL injection. And I'm actually seeing the results here from Pangolin, and it tells me some more information that I'm looking for here. Hit the execute, and it gives me that input there. And that's actually enumerating the actual database server that's behind the web application here via SQL injection vulnerability. I can also write files, so I can execute a command that will have database dump data to a certain file. If that database server has a web server on there, I can map to it. And I can actually read the registry of that remote database server as well. And that's what's being done here. And it comes pre-populated with all the important registry keys that hackers would need to know. You just hit the read button, and it comes back. I'm just going to highlight here the C program file. So that's what it actually retrieved from the registry of that box. Okay. And something I find really interesting as well is an Explorer-like view into the file system on that database server. So again, we're hitting it through SQL injection, and we're jumping out of the database server to the file system. I hit drives. There's all the drives on the SQL server. I double-click C drive, and now it gives me the entire structure of that database server. And what I'm going to do here is I'm actually going to read that rule file that we just looked at outside. The proper way outside of the tool, I'm actually going to read that here through Pangolin. Klog, open that, and we're going to open the cache rules.txt file, which is the file we looked at earlier, and look at those same signatures that we put in place. Right? So that's the same signatures that we looked at outside, but we're going over the web, exploiting a SQL injection vulnerability, and jumping from there to the operating system and reading that file, and that's all being returned to the attacker via web. So we had a clean server, again, 0 malicious cache entries. We've now exploited that via Pangolin. Now we're going to rerun Hypnosis here and see what it picks up. Again, we enter the instance name that we're looking for. And this can be run interactively on the server or on another system that has a connection to the SQL server. And it's come back with 59 hits and more cache entries. Now we've got 1,639 cache entries that are actually there. We're going to look at some of the results here. So we're going to open that results file again. What we look at is it tells you word for word exactly what happened. So Pangolin enumerated the database version, the name of the database instance itself, the current user. It checked what group or roles were on the system. And there's actually a lot of line entries here. And that's actually information that was retrieved from the file system. That's also captured as well in the cache, and that was picked up by Hypnosis here. As well as it read the registry. It checked the drives on the system, and it checked a couple folders. So all that information has been captured here. And as we slide right, that hex encoding there, those values, if I convert those hex encoded values, it will give me the registry hive, the registry keys that were read, as well as the errors in the file system that was actually accessed via Pangolin. So it's pretty in-depth. And the thing to keep in mind is this is any SQL server. It doesn't have to be hardened. You don't need C2 auditing. You don't need logging. You don't need a lot of network controls. Any SQL Server box you walk to, this type of information is in the cache, and as long as you know how to extract that, that's something you can use for incident response or to help verify or validate an attack. And again, looking at the top here, and that's just stepping through chunk by chunk. It's extremely long result files, but there's some of that car encoding, which again, you can easily translate within a database. And we'll be walking into a hex encoded value below by is server role member here, and that will just translate to sysadmin. So we know the exact role or group that was queried via Pangolin. And just before we jump to the upcoming slides, does anyone have any questions about the demonstration? I try my best to give a play-by-play, but does anyone have any questions about what we just saw? Yes?
Can Hypnosis be run as real time?
I'm sorry?
Can it be actively monitoring the cache, or is it just command line?
Yeah, well, Hypnosis is command line, but in 2 slides from now, we're going to talk about how to configure your service, which it can run in real time, and that's free. And we're going to talk about how to do that. But yes, it is possible to do that.
Because otherwise, if somebody ran a DBCC pre-proc cache, then it's going to be useless.
Yeah, well, there are specific tools you can run, whether you're looking from an operating system point of view to time stomp or something to cover your tracks there, or something you're looking to cover your tracks within a database server. Absolutely, there's ways around it. The point is the hacker focus is primarily in other areas as opposed to databases. But outside of manually blowing your cache away, restarting the SQL Server, et cetera, those things we talked about before, you're going to be able to pull that up via the cache. But yeah, it can run in real time as well. Okay. Are there any other questions regarding the demo we saw? Nope. Good. No technical difficulties yet. And based on Hoff, he stole my thunder here with my Vince from ShamWow here. It nearly fell out of my chair when I saw that. I was like, what are the odds? I'm the first session for Sector, and I got some guys use the exact same image. But as I'm stepping through, I went through a dry run of this just to get my timing down. And as I was doing the play-by-play with the Pangolin video, it felt like I was selling something. I'm not selling anything. This Hypnosis is free. You can go and you can download it. I'm not asking for donations. It's not free trial version. It's free. Take it, use it. There's no sales, no gimmicks. I'll leave that to Vince. Has anyone here seen Vince's commercials? Yeah. He's one of the best salespeople out there. I'm watching and I'm thinking, yeah, the Germans do make good stuff. That's exactly right. And I'm this close to pulling the trigger on these chamois, at least 2 different occasions. But he's good. I'll leave the sales with him. Hypnosis is free. Again, you can run it, and this is on any SQL server, and see what you uncover in terms of tracks. My recommendation for the rules file is to look at the usual fare. So a lot of the hacker tools out there, whether it's Pangolin, whether it's SQLMap, off-the-shelf products as well, because those are the same products attackers are using, as we saw with the attack on the AV site. They used a commercial, a very expensive product at Kinetics, to scan a site, because again, you could have thousands of entry points. No hacker's going to manually check them, but these guys use off-the-shelf products as well as hacker tools, and that's the combination that you want within your rule file. In addition to that, you want generic signatures, you're right. So you get the best of both worlds. That's my recommendation, but it will take whether you see a log entry or a web server entry that looks funny, or you see some sort of IDS event or something that's tripped upstream, you can actually qualify that within a database. And here's just an example of a snippet which tells you exactly what was enumerated. And again, that name is right there, and I can convert that from hex to something that's human readable, and it will tell me the exact database that I was looking at. And Hypnosis will be posted within the next few weeks on applicationforensics.com/hypnosis, so look out for it. Okay, and configuring your SQL servers, that's the point we just had here. The very first bullet I have here is if you can buy an off-the-shelf product, do it. You, regardless of the time you think you have, the knowledge you have, cannot keep up with the multi-million-dollar R&D budget of these vendors. So if you can get business approval, buy an off-the-shelf product. If you can't buy an off-the-shelf product, you can proactively configure your SQL servers to automatically detect attacks and alert you on that. And whether that's sending something to the event log, whether it's doing something else, you can automate that free through SQL Server. I'm just going to walk through that quickly. There's a TSQL script that I developed, but any of you guys who have a SQL background can do the same. It uses the same abstraction layer that Hypnosis uses, and you can use the same rules that Hypnosis uses to help detect attacks. Okay, and that being said, Hypnosis uses regex, which is a little bit more powerful than the wildcard features within SQL Server. When people think wildcards, they think just star, but SQL Server goes much further than just the star, the asterisk key. You can actually specify values and ranges of values and whatnot, similar to regex. So it's pretty powerful, but not quite as powerful as regex, but all that's built in within SQL Server. And of course, you can extend through CLR and other things to get regex, but it gets a little messy, so I'm not even going to broach that topic here. And you can schedule the script to run at intervals, whether you're using the Windows scheduler, whether you're using the SQL Server task scheduler, it's up to you. But you can schedule this to run every 15 minutes in real time if you need to, every minute, every couple seconds, every half an hour, 1 hour. And the script can be intelligent. And it will only check. If you have a 16 gig cache, it's not going to check your 16 gig cache every 15 minutes. It will only check the entries that were created or updated within that last scheduled interval. So it can be intelligent, so it's not just doing things without necessary. And a snippet of the script, it's too long to fit in one script, but a snippet of the script is here, which basically goes through, and you probably can't make this out, but I got a few rules in here for Pangolin, and some of the things that are commented out below are for SQLMap as well. So I've just experimented with this, with Pangolin SQLMap, and it worked quite well, actually. And the sample, the script I have, it writes it to the event log. And here's one of the alerts that are raised, which just tells you what happened, SQLMap banner enumeration, and gives you the actual syntax of the command that was executed. So that's the same hypnosis, like features or functionality that can execute in real time or whatever scheduled interval you're looking for. Okay, and part of that is good. For one, the point we had at the front here is in case someone manually wants to delete the cache to try and hide their actions, it will still be picked up depending on your interval. And likewise, we talked about that complex algorithm that SQL Server follows to determine how long to keep these entries in cache. If you have a cache that's set pretty conservatively, or interval that's set conservatively, you can make sure you can keep on picking up those entries that might otherwise be lost if you're just going to run this 2 or 3 hours, 8 hours, 2 days after an incident. All right? So we talked about detecting malicious cache entries and SQL injection attacks. What do you actually do after? Okay, so after you actually find the entry, whether it's through hypnosis, whether it's through something else, what do you do? Recommendation, of course, is to launch a full database forensics investigation. There's 33 documented artifacts that are all covered within SQL Server Forensic Analysis. One of the reasons to perform a full investigation is caching within SQL Server works well, but in some cases it works too well. You can come to a server through SQL injection, you execute a stat query, XP command shell, run a command. The SQL Server will create the plan cache entry. So it will actually create the plan. It will go to execute, and then it will come back saying, hey, I don't have access to do that. It's denied. That plan cache entry is still created, but the command didn't actually get executed. So yourself looking at just the results, whether it's hypnosis or something else, might come back, uh-oh, the attacker executed something in the operating system when they tried to, but it was actually blocked. So that's why the recommendation is to spin off a full forensic investigation. And just to give you a turbo review, I've talked about 33 artifacts, but I got a slide and a half that's going to walk you through looking at just the plan cache and transaction log, some of the things you can get out of that. Look at the plan cache. We've already covered this. You can get what people do when they enumerate the database to figure out the users, groups, the schemas. All that stuff is cached. Selects, insert, updates, deletes. I'm not going to spend much more time on the plan cache element. But looking at the transaction log, if you look at XP command shell, which is my favorite, when someone executes a command through XP command shell and they need to send the results back to the attacker, there's not an all-in-one step that will allow you to execute, send the results back via SQL injection. You need to execute, store the results within a temporary object, such as a table, and then query that table to get the results out. It's 2 phases. And from looking at the transaction log, you can actually quantify the actual results returned to the attacker. Because with database forensics, it's not just knowing the commands, it's getting results. Results of the commands on the database, as well as the results returned to the attacker. And looking at the transaction log, we're not going to cover how to analyze this, but it's well documented. I got a presentation, I got a white paper, it's all in SQL Server Forensic Analysis. This looks like Greek now, but once you learn the structure of what SQL Server does and how it stores data, a lot of this data is just overhead that doesn't apply. And only a small subset of that is the information that we're actually looking for. And these are the records logged in response to Pangolin from copying information from the operating system, again, getting the results and storing that into the table before it returned to the attacker. Qualifying that brings up the 5 rows we saw on the previous slide. Once translated, bring us these 5 lines down here. And based on these lines, can anyone here guess what command was executed at the operating system level, if those were the results? ARP, that's exactly right. So I like this example because ARP is dynamic. You can run ARP at 1 o'clock and run it again at 2 o'clock and get different results. And that just proves the power of database forensics to quantify results, not commands, because databases are dynamic structures. Commands won't help you out too much, but the actual results and being able to quantify the results is the goal of any investigation. And these are the results that were actually returned to the attacker. And there's more and more, of course, but I've captured 5 just to show you how to translate those transaction log entries to the actual information returned to the attacker via a SQL injection attack. Other possible things you can do, you can look at data disclosed within a database, recovery of binaries. Some people through SQL injection actually create temporary tables, and they have binary other hacking tools. They'll break up that tool and import that into the remote table, into a binary data field. And then on the database server, we'll actually combine that file, blow it out to the operating system, recompile it. They actually upload hacking tools. You can look at the transaction log. You can capture that information, rebuild the binary yourself, and get the actual file that was uploaded to the system by SQL injection. Likewise, you can get the logins, database user accounts, databases impacted, attackers' IP addresses, all that type of information you can get from doing an investigation. And as I mentioned before, additional details, I got a white paper on SANS on database forensics, a past presentation I gave at Black Hat, and actually Sector, I probably should have plugged that as opposed to Black Hat, but also on Black Hat, and step-by-step instructions, of course, within SQL Server forensic analysis. So in summary, is cache-based attack detection a silver bullet? No, there are ways around it, as we covered. The good point is that existing hacker focus is not on the database. There's not a single tool out there that automates anti-forensics within the database. There's not a post I've seen in any of the hacker forums I frequent. You don't hear about this stuff on the internet about hackers wanting to cover their tracks within the database or whatnot. They're focusing on the network. They're focusing on the operating system. They will, but they're not there now. And everyone here in this room who knows about cache-based detection is one step ahead of the bad guys by having an additional log that is 99.9% of the cases is missed by attackers, even if they are advanced and try to cover their tracks. And that's by looking at the cache. And the cat and mouse game, have fun while the good guys are a step ahead. And I just want to say special thanks to Naveed Islam, which is an extremely scary application security guy. But he's volunteered to do the peer review of Hypnosis to make sure there's no vulnerabilities in there. Some of you hackers can stay out of it, so don't bother. It'll be secure. And you guys were a great audience today. Thanks very much. Are there any questions anyone has? Don't be shy. Questions, questions. Yes?
Are those links that you have posted, are they on your site?
Yes, they are. Absolutely. And even references to the book, some of the sample syntax referenced in the book, all that's freely available on applicationforensics.com. No problem. Yes?
Are those signatures available too?
To tell you the truth, I experimented with a few, and I will post the signatures I experimented with. There's a book that was released by Justin Clark on SQL injection attacks and defense earlier this year. Justin's a great guy. He's gone through and documented signatures used by pretty much all the major tools. But I've gone through and I've captured that in the rules file, and I will make that available. Sure. Yeah. Are there any other questions? Yes. A good source. Aside from the points I'm posting on the applicationforensics.com site, the internet, there's all types of regex search expressions. For people who are primarily looking at web server logs, the thing you have to be careful with, though, is seeing a select statement within a web server log might be a red flag to an attack. Seeing that within a database cache is status quo. It's business as usual. So it is a somewhat of a new twist or a new focus, but looking at some of the existing stuff, you might be able to pick out new things. But applicationforensics.com will be the starting point for the regex expressions that I post. Yeah. Any other questions? Questions? No one. Relatively tame audience, which is okay. I don't know how to read into this. Okay, good. Well, thanks definitely for attending the session. Enjoy the rest of the conference.